Let's take a look at some more functions. And what we'd like to try to figure out is the domain and range of a graph of a function. Okay? So let's start with a couple functions that we know how to graph. If you don't know how to graph these, you might want to look at the previous lecture. But let's try to sketch the square root of x and x squared. Remember last time we sketched these two functions by getting a table of values and plotting points. And remember, the square root of x looks something like this. Okay? And x squared looks something like this. Okay? And what we're asked to figure out is we want to find the domain and range. Okay? That's our goal here. Find the domain of the function, find the range. Now, if you remember what domain is the set of all possible x values. Well, notice there are no x values that are negative. Okay? The only x values that we could talk about when we talk about this function are positive values of x or 0. So in this case, we're going to say that the domain, I'll just give it a capital D for domain, is the set of all values of x that are greater than 0. So one way we can represent the domain is in this notation, x greater than or equal to 0. Or interval notation, x can equal 0 or it can be bigger. This is the interval from 0 to infinity. This is usually the notation that you'll want to use. Okay? Now the range, remember the range is the y values. Okay? Now the lowest y value that we have is 0. And notice this arrow is going to go on forever. So the highest y value will be positive infinity. So the range is y values that are greater than or equal to 0 or 0 to infinity. Now notice the domain and range were the same. That's purely coincidental. Okay? This is not always going to be true. Let's take a look at x squared. Again, we want to try to find the domain and range. Okay? Again, the domain are the x values. Notice I can put any x value into this function. If I put an x value out here, it'll have a corresponding y value. Any x value out here will have a corresponding y value. So the domain of this one is all reals. All real numbers. We want to know how to write that in interval notation. But we'll say it's the set from negative infinity, or it's the interval from negative infinity to positive infinity. There's the domain. Now the range, let's take a look at that. The range is the set of y values. Notice the lowest y value is right here at 0, and this arrow means it's going to go on forever. So the range will be 0 to infinity. Okay. Let's do a couple more examples. Determine the domain and range of the following functions. Okay. Let's look at this one first. The domain. Now let's just say that each tick mark represents one unit. Okay? The domain, again, are the x values. Notice my leftmost x value is right here. And see how it's a closed dot? Okay? That means the leftmost x value is negative 1, negative 2, negative 3, negative 4. And the rightmost x value, notice this arrow goes on forever, which means that we can use any x value out here, and it will always have a corresponding y value. So the domain starts at negative 4 and goes on to infinity. Now the infinity is always an open parenthesis. Okay? Now the range. To get the range, we want to figure out what's the lowest y value. Well, the lowest y value is here, which is negative 2. And again, the arrow goes on forever, which means that the y value has no bound, or it goes on forever, which tells us that the range is from negative 2 to infinity. Okay? Now let's take a look at this graph. this is a bizarre looking graph. Most of you have had pre-calculus or a college algebra course or maybe a high school algebra course, so you've probably seen functions like this. Remember what these dotted lines are called. Those are called asymptotes. Okay. Those are imaginary lines. What these lines are lines that are in place where the function approaches these lines but never quite touches. Okay? So let's try to figure out the domain of this function. Well, domain are x values. Okay? So I start way out here. Notice this arrow is going on forever. It's going to approach the x-axis but never quite touch. That's what this means. So this is going to go on forever, which tells us that the leftmost is negative infinity. Okay? And then it's going to go all the way to this point, which is negative 1. But notice, there is no corresponding y value for the x value of minus 1. Okay? Which tells us that it's open there. So the domain is negative infinity to negative 1. And then we can go between the points negative 1 and 2. Okay? And what we'll use a union symbol in between. So the domain is negative infinity to negative 1, union with negative 1 to 2, union with the points from 2 to infinity. Okay? Now the range, all we have to figure out is what's the lowest y value, and notice this arrow goes down forever, which tells us that the lowest y value is negative infinity. The biggest y value, goes on forever in the positive direction, which tells us that the range is all real. Okay, you might want to review this again. Asymptotes can be a little tricky. You have to train your eye on what to look for. But view this a couple times, or come by the Polio Math Center and ask questions. We'll certainly straighten you out there.